once again, thank you all. My name is Nikita Mushenkov. I now work in positive technologies. I mostly write in Golang, and I love working with databases. Before Positive, I spent quite a lot of time working in a small company where I was running a lot of different projects, and from time to time made errors with databases, because of which everything just failed in production. Please raise your hands, those who has ever had database problems in production. Cool, cool. Now those with whom it all happened because of the wrong request that you sent or the wrong approach. Great. Maybe then you'll understand me when I speak. Okay, so what my presentation is all about. Initially, I wanted to speak about the operation of some database mechanism, like a typical lecture. But then I thought everything that you've actually learned didn't come from lectures, but from your experience. It's real-life situations that made me learn and change my ways of working. So I decided to reformat my presentations to share some of the funny errors I made, how I was fixing them, and how I was looking for them. I'll show you 3 cases. All of them are real-life, from production, painful. And it's some of those errors made me better as an engineer. Let's go now. What kind of cases would I like to talk about? There's a big ask in the public page. They cleaned one table and lost everything, and materialized view on the heavy. But I just understood that I spoiled the first case. Okay. A major request in a public page. So what really happened? There was a website to pass a poll on a public page with an admin interface. The admin was creating the poll via the admin interface and UI and was publishing it on the internet. In the front end, when drawing the page for the request, there was some GET request and some ID. So what was the database structure? In the center, there was the polls table and all sorts of auxiliary tables were linked to it that one needs to pass to draw the poll. There were blocks related to the poll ID. There were questions as such that were related to the blocks table. And some questions could be reused in different blocks. And there was also a table with responses, with answers. In addition to that, the poll had logical tables from the jumps. These were logical elements that determined which question was to be shown after a certain answer. And when the backend was accepting an HTTP request from the front end in order to pass all this information to the system, we were making an HTTP request from the front end, and we were converting it into an SQL request of this form. One would think that one big request to the database is an optimal solution. It would seem that one request from the front end to a single database is okay. And at that time, we were sure that that was an optimal way. And then the customer became creative and started creating real polls, adding 15 blocks with 10 questions in each block, 4 fixed answers to each question, and so on and so forth. And as you can guess, the method started to take longer and longer in each run. So how did we go about looking for the problem? At that time, we were strongly dumbfounded as to the reasons of this slowing down. And the first thing that came to mind was to add caching. But caching might, of course, be a solution, but one wanted to understand what was the real reason. What had we done wrong? And the first thing that we did, we checked the request schedule via Explain. And then we were quite shocked to see that the execution plan was like rolling through terms and conditions. There were almost 1 million lines of rows for a simple request, and the plan time was 18.8 milliseconds, but the execution time was like 6,000 milliseconds, or even more. And before making this presentation, I found a real-life example in old-time chats. It's condensed here, but it's from the old communication. So you see here that 30 million records are being selected, and it looks like it was supposed to take 18 seconds. Milliseconds, but it actually took almost 20 full seconds to execute. So let's come back to the question, to the old example that I showed initially. Let's imagine a simple poll. In the polls table, there's only one record. In jumps, there are 30 or 40 blocks, 40 records, 15 blocks. And now let's recall that everything that we connect via join, without filtering, without complexity, you have to multiply the number of records every time. So what do we get? In this particular case, the resulting table will contain 720,000 lines, and it's only for one request. And real fun begins when you add at least one record to the table. And so immediately we grow from 30 to 31 jumps, and after recalculation, it adds another 24,000 records, even though we've added only one record to the table. It's an excellent example how linear data addition results in an exponential growth of the results. So one would like to understand how to fix that. The first thing was to split the request. Well, the first request had joins anyway, but when analyzing how the tables were built, each join was made sequential. So it's not happening at the same time. And for the second ones, we select the required logic through separate requests. Why did we do that? On the whole, that gave us convenience and transparency regarding the growth of data. Later, we also added caching, and it helped splitting the code into several blocks so that one could reuse them. And indeed, so that one could select each entity separately. So what's the main lesson that I've drawn from this whole situation at that time? When we have to deal with a large number of joins, especially with complicated structures. It's very important to understand how the data volume is growing at the output. Even if the table itself can contain very few data, when joins are used, you can result in hundreds of thousands, even millions of lines. So before adding another join, I usually ask myself a question, or questions rather, whether I indeed need to join the data, how the number of lines in the resulting set growing. It's easily done through analyze. It can be done easier. Sometimes the second request with where in helps you a lot better than a join of the data that will result an explosion of data. The next case, so we've cleansed everything and lost. We've cleansed one table and lost everything. There was a project which we were gradually developing, and a lot of tables were key-linked to cascade deletion. Well, there were some additional tables, but initially we just had a category table and an events table. And we thought that considering that in the beginning there was a category and then you could enter an event, why, if a category is deleted, we should be deleting an event? If it's got deleted there, why doesn't it get developed here as well? But then a request came to add a scheduler for the same, a planner for the same event. So we thought, so why should we need to add the planner? And the same thing happened with tasks. And so the database got this whole wrapper of external keys around it. So, the developers had access to the production environment. The project was quite new. It was only 6 months old. And quite often it appeared to be easier to debug right in production. But what I mean debug, you just start quickly and see that everything was working okay and allow some time for the code to get populated. So one developer wanted to cleanse the directory, to play with it, to repopulate the dump. And he got confused with the tab delete from. And so he did a delete on the production. So deleting the directory, he deleted everything related to it. And it wasn't bad will. It was just human factor. So one tab was located in the wrong place. And the consequences were quite serious. The first one to see that was the customer, who opened up the UI and saw that there was nothing there. And he said, let's restore as fast as possible so that real bosses shouldn't see. So how did we restore it? First thing that we decided to do was to restore from backup, but there were no backups. Or better to say, we had a task for that in the tracker, but it hadn't been addressed. There was always something that seemed to be more important at the moment. So where did we restore the data from? Actually, anywhere. We found some old CSV downloads, screenshots that we had been sending to customers, some chat messages between developers. We were trying to restore it all. In certain cases, manually. In other cases, we would start some background processes to rewrite. So it took more than 24 hours to do it, and still some of the data had been lost. So What was nice, the customer, of course, was very upset, but treated us with a certain degree of understanding, which resulted in the project being born again from scratch. What do I do now in order never to get into the situation again? Firstly, get rid of cascade deletion. Data deletion should be understood and controllable. Sometimes, of course, you do need to have logic for that, and you either have to use restrict or run it through the code so that it will all be controllable. Also, quite often they use self-delete instead of physical deletion. So we add by adding deleted add to each table. Self-delete protects you from inadvertent changes, but makes the process a bit more paranoid. So delete is not really a delete, but an update for the code. Everywhere you have to process a new flag. So God forbid, the data that the user has just deleted shouldn't reappear in the selection. The new record that's being inserted, we can't be sure that it's a new record. For the database, it could be an insert or an update. So you immediately get into a situation where we have a lot more data. You either need to also add archiving or just, consider that. But as experience shows, data is always needed. And better to have more than not to have enough. Backups, as soon as you get a production environment now, we're always taking care of backups. It's at the required level of a project being commissioned. The project may not be considered released before you have set up the backups. And also, access to the production environment should not be allowed to everyone, not because we don't trust our developers, but because even the most meticulous person can make an error. Yes, sometimes you have to check what runs on the production, in the production environment. In that case, you should take care of offering rights only, or only read privileges, but nothing more than that. Next case, materialized view of a hard table, of a heavy table. So what did we have? What was the problem? We had a system where we were getting events with metrics every 15 minutes. And there was a complicated request that was supposed to pass the data required to build a graph with flexible filters. So everything was written in Postgres, in SQL, and gradually, as the data was accumulated, the request started to take longer to process. And then after some time, the customer came and said, something needs to be done about that. We keep opening the page, but the graphs are not yet there. And so they set it as an urgent, high-priority problem to solve. So what kind of solution have we thought of? First, that came to mind was about hashing, because it seemed that putting hashes everywhere won't take a lot of time, but because the graphs were quite flexible, every user could set one filter or the other. Each event had a ton of attributes, and events could happen, and that looked very flexible. So we had to give up on caching from the outset. Also, we're thinking about a more fundamental approach. There was event-driven development followed there. So events come, you make writes into the database, and one thought that this should be fixed by creating one more queue so that we could collect data from it. But because of the urgency, this solution seemed as one taking too much time. So then we recalled view and materialized view in particular. So it was supposed to be recalculating the materialized view in background mode and passed information via itself. As a result, a decision was made to follow the least loss path and to use a materialized view in PostgreSQL. What's materialized view? Regular view is just an alias for request, but a materialized view, it's the request persisted in the table that you can update manually. In this slide shows an explicit comparison between a regular view and a materialized view. And it seemed that it's indeed what we want exactly. We didn't need to update data too often. Once every 15 minutes was enough. The fast events or fast-processed events because of the pre-calculated data and simplicity. So after implementation, everything looked fine. Select from material view was flying fast. The graph would load in no time, and the users were happy. And one thought that everything was going to be good. But is everything going to be good? Well, it turned out to be not that simple. After some time, users started complaining, why am I not getting a graph? Why does the page take so long to open? We started reviewing. Everything was running fine in the test database. And also, when we released, it was fine for everyone. It was working really fast. So we've decided to open PG stat activity, and then we saw a whole queue of refresh materialized view commands. It struck us. What was happening? What was happening was that each refresh was blocking a record from materialized view. So while the materials view was being updated, no other requests could have access to it. And actually, if you looked under the hood, refresh materialized view was about a drop of a materialized view and recreating it again. We were looking for a fast option and saw the word concurrently in documentation. On the whole, we had experience. So one, we put external things in the database. You can just create an index and it can block. But this create index containment, it does something and you can start using the database. So, what concurrently is all about as part of the materialized view? It's a polite version of a recalculation that does not stand in the way for the user to read data from the table. That is to say, all selects at the moment of refresh are available, and they allow updating materialized view without read blocks. So as I said, selects by view run on parallel with the updating, but there's a unique index. Why? In concurrent updating, Postgres has to compare what exists in materialized view, what has been changed. So, without the index, it appears what you're getting is that the database will not just allow you to make the update. So one thought that why don't we do concurrent updating? We added a unique index on view. We updated the request to refresh. In the past, it was just refresh materials view. We added concurrently, and so it was. We just added one word. Then we cleansed the request queue to refresh from the database. And it turned out that the data is being updated and no blocking it is happening. And then we thought we won. Or not. After some time, a user started complaining again. Why is the data obsolete? Again, we started to look at it and almost immediately opened PG stat activity and saw a whole line, a whole queue of refresh materialize view concurrently commands. So we nearly despaired. We didn't understand what was happening. Why it happened this way? Currently is only about the absence of blocking of read blocks during create materialize view. But actually, the command is executed in a single thread, and while it's working, while it's running, others are put in queue. So only those data sent that change in the source table. But because there's certain logic, this command takes even longer to execute than without this parameter. And also this operation is very heavy on time and memory consumption. So it took considerably more than 15 minutes to update. So it wasn't good. As a result, we had to completely give up on materialize view. Yes, the idea was good, fast reads, pre-calculated data, but in practice, the updating turned out to be too heavy, especially if new data was coming too often. So we just redeveloped it to use a regular table with a gradual recalculation as the data was arriving. We lost a lot of time for that. But as a result, we built it so exactly the way that it should have been from the outset. So what did I take out of this? A materialized view in Postgres is a really cool thing, but there are subtle points. When the data is updated quite seldom, once an hour, once a day, I would say once an hour is even too frequently. So, for instance, you recalculate overnight, and then you get a table that will be valid for the date. And most importantly, that living with the obsolescent data is something that you can afford. But if you do it fast, frequent, and safely, it should be like a real table with either a background process or some other mechanism. The main lessons learned that I have taken out of this case. First important lesson. One big select is not always a good idea. And when you want to fit everything into a single SQL request with a lot of joins, it appears to you as an elegant solution. So you get all the requests into one, you get an HTTP request, we immediately translate into SQL and everything looks fine. But after that, more often than not, you are going to have problems with performance, support, scaling. And if the join turns into a monster containing a lot of tables, this is actually a signal, a message to you to start thinking about channelization or splitting the request to several. Quite often, it offers you a better performance than doing just one.
Also, think about the growth of data beforehand. in your test data, in the first 1,000 lines, everything is fast. Problems pop up later in a year when you have more data, more users, more workload. And if it works now, it's all right. But think what will happen next, what will happen tomorrow, next year. Think about it in advance. Do we need indices? Do we need partitioning? Are we going to use caching? Maybe this can be done not always, not from the very beginning, but keep it in your hand. But for the time being, it's all right. It can be done. It works. But so that caching wouldn't be painful later. Next important lesson is that automation at the level of databases isn't always reliable. It's very convenient when you have external keys, when you have scalable architecture. Everything is automatic, simple, elegant, but in practice it can be a catastrophe. Cascaded remote operations can delete the data or invoke the data that you didn't even imagine that you needed it. And the first person who is going to notice it is the customer. So it's much more secure to use soft delete and manage it manually. And finally, the most important thing, read the documentation always. If you want to use a tool for the first time or in a non-standard way, sometimes you want to do it fast, even if, especially if syntax is understandable. So nothing is complex, everything is simple, but the devil is in details. Somewhere you will have blocking, indices, queues of indices. Everything is described in the documentation, but we never read it. First we install, then we read. In my case, if I had read it before in a motivated way, how refresh works, how other things work, then I would have saved a week of my time and did everything properly. And to conclude, I showed you 3 cases. All of them are real. All of them are mine. In some cases, I do too much with joins. Sometimes I deleted what shouldn't be deleted. I trusted what shouldn't be trusted. But I understood a lot of things, and I understand that errors brings in experience. Even the most experienced people make mistakes. This is not dangerous, but do not ignore them. Try to find solutions and do not repeat your mistakes. And the main thing is make conclusions, be more wise, and be a better worker. Thank you.
Да, алло. Никит, спасибо.
Hello, thank you, Nikita. Now it's next slide, please.
И не тот слайд включили.
No, it's a different slide, and it's not the right one. Anyway, now.
Ну, давайте до конца тогда презентации.
Well,
будет QR-код.
In the end, we shall get a QR code, evaluate the presentation, and for all those who leaves your feedback, we shall have a lottery, and the winner will get a book about adventures of Lovelace and Babbage. Now, questions and answers. Are there any questions? Thank you for your honest presentation. You showed us excellently that scalability opens the true nature of business processes, and our model doesn't always match that nature. I want to ask you, do you think when you scale up your Postgres conclusions, can we use those conclusions with other environments?
Да, конечно, я думаю,
Yes, of course. I think in many cases can be applied everywhere. ClickOut, for example, they have materialized views. They work in a similar way in ClickHouse. You can break everything with one request.
и
And
можно удалить там что-то.
also, you can delete something which shouldn't be deleted. Yes, I worked in Postgres, but many things match other databases and it can be applied.
Спасибо. И отдельно
Okay, thank you.
чтение документации.
And a special like for documentation reading.
Представьте,
Next question, please.
Меня зовут Сергей.
Hi, I am Sergey.
Меня тронула история.
I liked the story about materialized view. Let's do it faster, and then let's do it in the right way. Was there a capability of, did you have the time for rebuilding? You did it fast, and how fast did you realize that it doesn't work? You just ran it, and immediately, yes, it took us one day. The customer on the next day saw it's all wrong, and we decided to roll back and ask for more time, and it took us a week and a half to do the right thing. So it wasn't a thing that could be waited. You couldn't do something temporary and then normal. No, we rolled back everything and then redone everything.
давайте справа, молодой человек.
Да, здравствуйте. Зовут меня Ярослав. Никита, привет.
I'm Yaroslav.
Скажи, пожалуйста, как относишься к
What do you think about concurrent usage of
deleted app?
cascade and deleted ad at the same time?
Ну, ты имеешь в виду, чтобы была автоматизация?
So automation
Ну, скорее,
for those delete commands. If you want delete cascade, you can do it through delete. And if you want to delete business logic, then delete add. I believe that if you want to delete a lot of things, do it through the code, through several requests, and see what exactly is deleted at each stage. And as far as I understand, you didn't have a lot of time, so you rejected external analytics. Yes, we wanted to do it fast, very fast, just a couple of days. And we believe we could do it, use select from, and migrate with the background processes. We did it very fast. Thank you.
Молодой человек.
Привет,
Now-
меня зовут Олег.
Hi, I am Oleg.
Спасибо, что поделился
Thank you very much.
горьким опытом.
Thank you for your harsh experience.
Ты говоришь, от него по факту
You said you rejected the solution. Why didn't you use
incremental refresh.
incremental refresh function?
То есть не полное, а
Not full refresh, but incremental refresh, partial refresh. Yes, I learned about it after we have redone everything. Yes, it was a real new technologies. When we redid everything, we didn't want to touch that system again for some time. Perhaps at that time, when it happened, it was 5 years ago. If I would be more experienced, I could use that, but no one in the team knew about that solution, and we improvised.
поправить ситуацию.
So it could help.
В такой
Right.
похожей ситуации или в твоей
Yes, in the similar situation or in your situation, yes, it looks theoretically looks like that. But in any case, there would be a lag for update, about 10, 20, 30 seconds for updating or refreshing. And, well, of course, there was a graph and metrics on top. First, metrics were refreshed, and the customer didn't see them on the graph, on the chart, because the chart refreshed later.
Потому что одновременно данные появлялись там и там.
So we needed simultaneous or concurrent refreshment, data and charts. Thanks.
Пожалуйста. Давайте, вы первые подошли справа.
You're welcome. You are the first.
Спасибо за доклад.
Hi, Nikita. Thanks for the presentation. My question is like this. Tell me, why couldn't you store the data in cache
В общую кучу в кэш.
and
И,
so
собственно,
put all the data in cache and synchronize it with the database? Wouldn't it be faster?
Может быть, это было быстрее, но
Perhaps
как
faster,
обычно
yes,
бывает,
but
что когда ты начинаешь
what do you do at the beginning when you start a project? You don't know what you will have in the end.
вначале вообще не знал, что будет
At the
какие-то
beginning, I didn't know anything about charts, and it looked as if it's viewing certain events. But later, when we saw everything, we scaled it up, and we couldn't redo it at that stage. But from the very beginning, you cannot expect everything you might have if the customer doesn't know that.
сразу придумать.
It was quite difficult.
Спасибо.
Thank you.
Меня зовут Алишер. У меня такой вопрос.
I am Alisher.
За исповедь.
My question, thank you for your confession. It was nice that you shared your experience,
Это очень важно.
your
С этим сталкиваемся.
mistakes, which anyone can face.
Больше, наверное, про технику.
My
Я, наверное, не очень
question
знаю
is
простой,
about
но
hardware.
Нельзя ли было восстановить данные
Could
через
you
журнал
restore the data through the wall
Там был
log?
просто настроенный по дефолту Postgres, который
We had Postgres, which was tuned by default,
Понятно.
and we started using it.
мало чего.
And by default, a lot of things were turned off.
Что стали отбирать доступ у разработчиков.
It was nice that you started this thing and ended it properly.
Записи не будет слышно.
Добрый день, спасибо большое.
Hi, thanks for the presentation. I would like one point about analytics.
Прошлый вопрошающий сказал,
The previous person said you can merge the 2 points. When you start the project, you can tune the database in such a way that the transaction log and the database is mirrored, and analysts can choose anything from that log. You said there are some conclusions that you made. Maybe this idea could be added to your conclusions
итог вот того, о чем вы говорили.
as a result of your
Ну, то есть
experience.
бэкапим, и желательно,
Logs are backed up
журнал заодно
always,
использовать, чтобы
and
какой-нибудь
that
зеркало
log
всегда у тебя
should be used for the mirror
лагом тем же будет
with a 15-minute lag,
лазит.
and let analysts go there and analyze.
Кейс произошел
That case happened when the project was 6 months old. After a year, when we got analysts, we reached that stage. But at the beginning, we didn't have enough resources to add one more database for replicas, for backups. Then we got it, such resources, and it helped us a lot to reduce the workload
Ну да, это
for
скорее да,
analysts.
потому что у заказчика сразу
Yes, the customer should be asked two database servers from the very beginning and production
миграцию катануть, проверить.
for migration, for checking, and so on. Thank you. I agree.
Никита, привет. Меня зовут Алексей.
Nikita, hi, I am Alexei.
Подскажи, вот такой вопрос. у тебя
Please tell me, you said you are
вопрос управления.
team leader.
Что сделали?
It's a management team. What happened to the person who killed everything?
На самом деле, ну, ничего.
Actually, nothing was done.
Он
At the beginning,
работать,
he continued working. Then he decided to join another project,
Серьезно, ничего
and then he left the company. But seriously, we didn't punish him.
очень сильно был лояльный и
The
действительно
customer was very loyal and understandable, and he forgave us. Any more questions?
Ну,
No.
теперь тебе
So,
самое тяжелое
Nikita,
сейчас будет
now
достаточно
the
ответить на
heaviest
вопросы. Я смотрю, ты
part
прям
is
готовый,
to recall
попросить, чтобы
all
кто-то
the
встал, кто
questions.
задавал вопрос.
Please stand up, all those who asked questions.
Ты теперь примерно помнишь?
Which question is the best? Let's recall who asked everything. Well, it's
Я
hard
напомню, там был
to
тоже
recall.
материализованный
There's a
представление
question about materialized views,
тебе лайк
about
прочтения документации.
the like for
Был просмотр
documentation reading, then
И вот я тут там первый...
also I forgot about other questions. I started recalling the question,
предложение на то, что
or a proposal that material view can be refreshed incrementally.
Да.
Somebody asked that,
Подходите, пожалуйста, к нам.
proposed that, okay, a person who said that, please come and get your prize.
Это книжка.
This is the prize. It's a book from the Peter editorial house.
Никит, отойди, пожалуйста. Нет, наоборот, сюда чуть-чуть.
Nikita, please come here.
Слайд предыдущий по поводу...
There was a slide about the prizes.
Не сканировал QR-код и не оценил.
Please scan the code, evaluate it, give your feedback.
Еще раз. И давайте еще
Do
раз
it once again, and let us thank Nikita. It was his first presentation.